Good morning, student. Today we are going to learn about design hierarchy, regularity, modularity and locality. After completion of today's session, you are able to explain the design hierarchy, define regularity, modularity and locality. So first we start from design hierarchy. The use of the hierarchy technique involves dividing a module into submodules and then repeating this operation on the submodules until the complexity of the smaller parts becomes manageable. So hierarchy in circuit design refers to the creation of higher level cells based on lower level cells. Means the hierarchical design approach reduces the design complexity by dividing the large system into several submodules. This division is done until it reached at an understandable level. This type of approach is known as divide and conquer. As we know, in a VLSI design flow, there is 3 different domains are present, that is structural domain, behavioral domain and geometrical layout domain. So hierarchy structure can be described in each separate domain. Let's see the diagram of a CMOS 4-bit adder. First, the adder decomposed into 1-bit adder. Here these are 1-bit adders. Then again divided into carry and sum circuits and finally into individual logic gates. These are carry and sum circuit and these are individual logic gates. Because the complexity of the 4-bit adder is more than a simple logic gates. So it is easy to manage logic gates than a complete circuit. So this is all about design hierarchy. Next we discuss about regularity. Regularity means that the hierarchical decomposition of a large system should result in not only simple but also similar blocks. Means divide the structure in simple blocks, but simple is not sufficient or enough. We need similar blocks also, as it helps to reuse the design again and again. Once designing of one block is completed, we save it in a library and use it for other similar blocks. So example is the design of array structures consisting of identical cells. Array structure means more numbers of structure of similar blocks. So this is the design of 2:1 multiplexer. So it is consist of 2 inverters and 2 tri-state buffers. So if we design one inverter and one tri-state buffer design, then we use the design for the other ones also. If this circuit contains more number of inverter, then also the same design can be applied for the other inverters. So this is the advantage of regularity. Next we discuss about the modularity. So modularity in design means that the various functional blocks which make up the larger system must have well-defined functions and interface. A integrated circuit broken into smaller submodules allows for easier management. Means managing the submodules is more easier than the main larger module. So the separate modules are easier to test, implement or design. These individual modules can then be used to develop the whole circuit or whole module. So modularity minimizes the risk of ending up with circuit errors and also makes it easier to spot errors. Modularity allows that each block or module can be designed independently from each other. Means the modularity allows development to be divided by splitting down a circuit into smaller modules. This enables developers to work simultaneously and minimizes the time taken or development as modules are independent from each other. Means number of developers work parallelly on the separate modules of the same circuit. So modularity is a key weapon in reducing with complexity in a large circuit. When we break everything down into smaller parts and make each person responsible for a certain section, it can improve the quality also. Next, locality. The concept of locality also ensures that connections are mostly between neighboring modules, avoiding long distance connections as much as possible. Locality extremely important for avoiding long interconnect delay. So the main purpose of locality is to reduce the length of interconnect in order to reduce the complexity and interconnect delay. So this interconnect delay is the difference between time a signal is first applied to the device that connected to the interconnect and the time it reaches other device connected to the same interconnect. It is due to the finite resistance and capacitance of the interconnect. So as the length of the interconnect increases, the interconnect delay also increases. So we try to minimize the length of interconnect by doing connection between neighboring modules. So this is all about design hierarchy, regularity, modularity and locality. Thank you.